Question 2. Calculate friction loss in the pipe of 300 feet with the flow of 160 GPM at 120 water temperature passing through 4-inch nominal standard weight steel pipe with surface roughness coefficient of C equals to 100. In this question, you would start by searching Darcy-Weisbach equation. So you can just type in Darcy, and this is the formula you're going to get. So the friction loss equals to friction factor, length over diameter, velocity to the second, divided by 2 gc. This is a gravitational constant. So in order to do this problem, we would have to first find the Reynolds number. So the Reynolds number equals to velocity times diameter divided by kinematic viscosity. So for kinematic viscosity, all you have to do is you go to the table of properties of water. You can just type in into the PDF file properties of water. You're going to find the table. And for 120 degree Fahrenheit water, the kinematic viscosity is going to be 0.609 times 10 to the negative fifth feet squared per second. Now, for the velocity, we can just use standard pipe tables. So you can just type in steel pipe friction tables. And those friction tables, if you look at the tables themselves, they're for coefficient of C equals to 100. And as values of your C change, you have to adjust those values in the table. So for example, if C was equal to 110, you would have to multiply your value that you have in the table by a factor of 0.84 to get adjusted value. But since this problem gives you C equals to 100, you don't have to do anything. You can just interpret it from the table. So the velocity at 160 GPM with 4-inch diameter will be 4.03 feet per second. We can plug this in for our velocity value. And if you look at those same tables, your diameter will be 4.026 inches. This is the inside diameter for the pipe. And we always use inside diameter in these types of problems because the water only touches the inside flow of the line. So you have to find out the inside diameter of the line. In this formula, the diameter should be in feet, so we divide by 12 to get feet. Reynolds number is unitless, so all these units cancel out, and you'll get 200,000, 22,000, 14 for your Reynolds number. Usually, in order to use our chart later on to determine our friction factor, I like to simplify these numbers. So in the chart, use 2.2 times 10 to the fifth power just for the easier interpretation. You'll see later how this helps you out. Now, step 2, you have to get roughness factor. So roughness factor is a value of diameter and this roughness factor. So if you look into the chart itself, you can type in Moody. So this Moody diagram will have the relative roughness as roughness over diameter. So for roughness, I would go with 0.0002 feet. And if you look at the table for let's see, galvanized iron or commercial steel, you'll see that this value usually ranges between 0.001 to about 0.0003. So we kind of pick the middle ground for this. Now for the diameter, we already have this value. This is 0.26 inches, but we want to keep it in feet, so we divide by 12. And this value is unitless. So this gives us a factor of 0.0006. Now, if you look at your Moody diagram, you'll have something that looks like this. This would be our step 3. We need to get this friction factor, which is dependent on relative roughness and Reynolds number. So this diagram will have Reynolds number on the bottom, and it will have this surface relative roughness on the side. And if you look, the friction factors are going to be here. And they'll have a bunch of lines that go something like this, depending on your relative roughness. The trick to this is you have to find your relative roughness. So our relative roughness is 0.006. Over here, our Reynolds number, let me just look, it was 2.2 times 10 to the power of fifth. You'll have to interpret these two numbers to get your friction factor. So in our case, the friction factor that kind of closely matches these two values is 0.019. Finally, we go to the last step where we have to plug everything into the formula to get our friction factor. So friction factor was first in this formula, then it was our distance over diameter, velocity to the second, divided by 2 times GC. Now, friction factor was 0.019. Our distance from the problem was 300 feet. Our inside diameter was 0.026 divided by 12 to keep it in feet. Our velocity was 0.3 feet per second to the second power. 2 multiplied by GC, which is a gravitational constant of 32.2 feet per second square. So once we do this calculation, our units will be in feet. And you can clearly see this because these units will cancel out. Feet will cancel out. We'll have feet here left, and second square will cancel out with second square. And you should get 4.28 feet as our final value for friction loss.